Yeah, dear students, in this video, I explain how to make a turbofan. Okay, turbofan consists of an aerofoil shaped blade. Aerofoil shape. If you see the cross section of this aerofoil, right? Aerofoil like this one. This is the aerofoil shape. So yeah, we have at one section, right? At the hub section, the shape of the aerofoil is like this one. Hub means here near the shaft. Okay, and at the middle section, the shape of the aerofoil is like this one, and at the top tip, okay, say at the tip, the shape of the aerofoil is like this one. Okay, it's constantly reducing size, okay, from the hub to tip, and to make this aerofoil shape, right? So what we have to do? So we can go to NASA website and download the aerofoil shape for particular, yeah. So download the aerofoil shape, right? So the coordinates of the aerofoil shape for particular lift and drag, okay? Particular lift and drag forces. Yeah. So, but I don't have those coordinate files, right? What I do is, yeah, import this picture to Catia and trace this aerofoil shape using sketch tracer, okay, and use 3D curve to trace this one, okay. So we need two 3D curves, and after that one we can use generative shape design, okay. So that is what we do. Yeah, okay. So let's do that one, okay. Let's do that one. First we have to download this picture, okay. Download this picture. Fan top view. The picture is in the format PMP format, okay. So Catia cannot read other formats, only BMP format and TIFF format, okay. So PNG formats it cannot read. When you screenshot, right? When you screenshot, automatically the format is PNG, okay. PNG format. So we have to modify that one to BMP format using Paint or something, okay. So yeah, make sure that you have a BMP picture or TIFF picture before uploading this one to Catia, okay. Download this one. And I already downloaded to download folder, okay. Then start Catia, and here shape we use sketch tracer, okay. So first sketch tracer to import the picture from outside to Catia. Yeah, so because it's a top view, so yeah, before importing or after importing, right, should move to top view. This one is top view, okay. This one is top view, and also shading with material option should be the render view. Okay, this one, shading with material option, you should select these two, okay. But before importing, make sure that you are in a particular view, right? So right now this is top view, okay. I am importing fan top view and shading with material option, okay. Shading with material option, okay. Yeah. So now, yeah. So use this one. Okay, use this one, okay. Yeah, so downloads, go to download folder, yeah, fan top view, Okay, is top view. Okay, and yeah, I want to keep my origin is here. I want to keep my origin here or here. It's up to you. Okay, you can keep anywhere if you want, right? Origin here, because I know the coordinates here. Okay, so you can keep here also if you want. Keep your origin here, center point, and adjust other dimensions. Okay, so by default when you import a picture, right, it has some size, but you have to adjust according to your size. Okay, according to what is our size, right now. Right now the size of the shaft, length of the shaft is 250 and the diameter of the shaft is 50. Okay, you can see the diameter, diameter of the shaft is 100, radius is 50. So you can adjust either length of the shaft or diameter of the shaft. Because I know the dimensions, I am adjusting those. Okay, so based on your picture, okay, your picture may be different. If this is different, right, so then you have to adjust accordingly. Okay, for example, it is 2500, right, adjust this picture size to 2500, so that Catia can recognize this one as a 2500 millimeter length. Okay, yeah, so minus 250, not 250, minus 250, because yeah, right now x direction is downward, right, but I am keeping x-axis here and this is in the other direction, right, so minus 250. So when you adjust this one, right, automatically other one is also get adjusted. Okay, get adjusted. So for here, yeah, okay, if you are more careful, right, you can zoom, right, you can zoom if you want to adjust more accurately, right. So select this is the that one is the center point, and this one is okay, and minus 250, minus 250. So this one is, if you adjust one is enough. Okay, either 50 or 250. Okay, so I think this is okay. 50.294 is okay. We are just making approximate view. Okay, not full view. Yeah, now we adjusted the size of this picture, right, according to our dimensions, size of this picture. Now this one is 250. So if you adjust one length, right, automatically all the same, right. So and now what you do, we do a product, select this product and open the freestyle design. Okay, in order to make freestyle, in order to trace the curve, right, we need to use 3D curve option. So 3D curve option is available in freestyle design. Okay, we don't have 3D curve option in generative shape design. Okay, so yeah, we can start from here or from here. If you want, you can further zoom and adjust the line. Okay, yeah, we can do it later. So yeah, click very close and control points option. I'm selecting the control points option. So this will give you a smooth curve, control points option. So I will also upload a 3D curve demo. Okay, what are the different options available for 3D curve, and this one, and you can change the color, right. View toolbars, graphic properties. Okay, graphic properties. So this gives the graphic properties toolbar. Okay, this one. So like you can change the color of the line or color of surface. You can change the thickness of the line. Okay. Okay. So yeah, right now this is not perfect, right? So you can double click and to adjust according to. Yeah, I think this one is okay. click on OK. And again, another curve is needed, right? So we cannot make a complete curve, right? With a single curve. With single 3D curve, we cannot close, okay? Because it's a polynomial, right? So start point and end point should be different. Another curve I am doing. You can start from here or other side, okay? So 3D curve, make sure that you are seeing this circle. This one is contact. Okay, don't start from here or here. Okay, here. It's a contact. Touching this one. And make sure that the last point touching this one, okay? Touching this one, the last point. It is in contact with this one. Yeah. First point of the curve, first point of other curve. I think in class, right, you are doing like this one, okay? Not like that one. Yeah, here. You should touch it, the first point. And after, right, so you can change the graphic properties to, if you want, you can change, because it's difficult to recognize that one, right? And here, so here we have point contact, not point contact, tangent contact, okay? So tangent, these two are smooth curves. So tangent contact, and you can adjust, right? Remaining sizes. This one. If you think this is not perfect, right? You can do it until you get a perfect shape. Okay. Click on. We have two curves which are perfectly matching with the aerofoil, the bottom aerofoil surface. Okay. The bottom one. And you can change the thickness of this line to 0.7. Okay, now what we have to do right here, make sure that, okay, yeah. So tracing curve is finished, right? And you can hide this picture, okay? Don't delete, hide. So make sure that you do not have any extra projections here, okay? Extra projections here, because I already give tangent, right? Tangent surface, there is no extra projection. And in class we join, right? So you can join, or other way, better way is trim. Okay, trim. You can do trim here in freestyle design, or from now onwards I use generative shape design. Generative shape design. Okay. Yeah. So generative shape design, we have two curves, right? So 3D curve 1 and 3D curve 2, right? So make sure that you don't have any extra projections. Okay, or so for that one, better way is use trim, not join. Okay, we use join, right, in class, trim. So this one, and as trim into pieces. Okay, pieces, trim into pieces. This one and this one. Okay, 3D. So click on OK. So trim, what it do, right? If trim, if there are some extra projections, right, it will delete automatically. Otherwise, if there are no extra projections, just join them. Okay, join them. Yeah, and trim. We don't need join here. So now it's complete one trim. Okay, one trim. And now, yeah, here we have some round corner here, right? So in the picture, it is not shown clearly. But here we have a round corner, like here, this side. So it's not a sharp corner, not sharp corner. So round corner, radius is 0.3 millimeter, 0.3 or 0.5 millimeter you can use. Better use 0.5 millimeter, okay? 0.5 is not provided. So yeah, you can also consider a sharp corner here, but it's not good for design. Okay, so change that one, right? So change this corner with some radius 0.5, right? How you do? So below the circle option, 3D corner. So 3D corner and corner on support, because it's a two-dimensional curve, right? So corner on support, corner on vertex. Vertex means over here, and 0.5 millimeter is the radius. Click on OK. Okay, now you see this one. So this one is the final one, what we need. Okay, what we need. This one is the final one. So now what you do, so we construct a cylinder. So cylinder, right? Like this one, cylinder. Okay, this one cylinder, or you can make yeah. So go to YZ plane and make circle and extrude. Okay, or you can make a cylinder here directly. So where is cylinder? Below the extrude we have cylinder. So cylinder center point is 0 comma 0 comma 0. We don't have point, right? Create 0 comma 0 comma 0, and the direction is x direction, right? So you see this one is x direction. So cylinder is along this direction, and radius of the outer 50, right? And length of the cylinder is 250. Yeah. So yeah, actually this side, right? This side 0, and another side, the reverse side 250. So that one is a cylinder. So now from the inside, projection is not doing, right, sometimes. So yep, actually we have to project this one to here, right? So yeah, you can use translate, right? You can transfer this one to top, and like that one we have how many? We have 3 cross sections. So one is at the hub, right? One is at the hub. Hub means on the cylinder, and another one is at the mean, right? Mean means here, and another one is at the top. Mean radius. Mean radius means I think here the mean radius, and another one is at the top. So hub here and top. So we have to project. Okay, project that one too. Actually, you have many cross sections in between, right? But I just used only 3 cross sections. So you can use as many as you want, okay, to get more accurate profile. Okay, so I copy this one through three times. So how we can copy? I can use yeah, this one, or you can use yeah, a pattern also you can use, but copy, translate makes individual, right? So we have to copy along the vertical direction. That one is z direction, and sorry, element to copy is this one, corner, not trim motion, corner. Okay, after making the corner, right? So direction is z axis, and distance is, the first copy is at the hub. Hub radius is 50. Okay, distance. And again, one more copy we need, right? So like that, three blades we need, right? Three cross sections we need. The same element to copy is 3D corner, or you can make this one, right? If you copy this one, distance is different, but you make a 3D corner a copy and a jet component, and 100, and yeah, so because hub radius is 50, and mean radius is 150, diameter is 300, right? The tip radius is 250. So 150. So 150. Okay. Again, translate. So z-axis, the direction, sorry, element to copy is this one, z-axis, and this one is 250. Okay, yeah. So now, yeah, we don't need this one, right? Hide this, and we have to project this one, right? This one to cylinder. Okay, so project this one to cylinder. Okay, so projection, project this one to cylinder. So that one, hide the translate one, because we don't need, only we need projection. So like that one, yeah, if you want to get more accurate result, right, you can project that one to another cylinder. Okay, here make another cylinder, make another cylinder here and project that one. But I think no need to be that much accurate. Okay, even though you project or not, it will give same result, I think, because 90 degrees angle, right? But first cylinder you need a projection, because you know the profile should touch the cylinder. Okay, and now what you do, we have to rotate this one and make smaller, and we have to rotate this one and make it smaller. But for that one we need a center point of this. So center point of this one is what? Center point of this one, right? Center point. So when I see from the top, the center point is here, right? Center point is here. So what is that one? Center point is exactly, it is 125 millimeter away from the x-axis, and yeah, from the z-axis it is for first cross section, right? It is because hub radius, mean radius is 150 millimeter away from the mean radius. This one is 250 millimeter, right? So make 2 points. So okay, so make a middle point here, middle point, right? So point. So what is the coordinate? X is equal to minus 125, because total length is 250, right? So middle, in the middle I want to make, so minus 125, and y-axis is 0 and z-axis is here. Z-axis is height of this one, right? So that one is 150 mean radius. So 1 point, and again another point, right? So yeah, x is same, but this one is 250. Make a line. We can do that later. And now we have to make this one smaller, right? Smaller by 0.75 times, because you know scale of the aerofoil, right? If hub cross section is 1, right? Mean cross section is 0.75, and this one is 0.5 times. Okay, so yeah, so make it that one smaller, right? Scale. You can do all these things in 2D also. Okay, 2D also we can do all these things. So elemental scale is this one with reference to the center point, right? And ratio is 0.75. And now I don't need this one. I know I need only smaller one. Same here, scale. Element to scale is this one with reference to the center point, and this one is half of the main one. Okay, size is half of the main one. And now we have to rotate this one by, yeah, like this one. Okay, we have to rotate, right? So this one about 30 degrees. Okay, and yeah, because our x-axis is like this, like this one here, right? Minus 30 degrees, and this one is minus 60 degrees. So rotating, okay. Yeah, for rotating right, we need to create a line. So with respect to this line, we have to rotate, okay. So we can write line. So joining this one and this one, rotate. So you can also do this one, rotate right in 3D, in 2D, okay. So project this one using project 3D elements, okay, and rotate. So all the things I am doing in 3D. Element to rotate is this one, and axis of rotation is this one, and the angle is minus 30 degrees. Okay. So you hide this one, hide. So what I need is just rotation. So similarly, again, one more rotation we need. Right here, elements to rotate. This one and axis is same, and minus 60 degrees. Okay, and you hide this one, hide. And we don't need this line, hide. We don't need this point, hide and line. Okay, you can hide all these things. Yeah. So now what we do, we use a multi-section surface to join this one and this one and this one. So multi-section surface. So you can use blend, but blend only, join only two, right? And doesn't make a continuous multi-section. And make sure that you have a closing point here, here, and here. Sometimes if your closing point here, right? For example, if all closing points are here, right? You can replace to here, right? Actually, in this case, you don't need to replace, but sometimes if one closing point here and another closing point here, right? And you have to replace that one, okay? So I'm using Control Z. We don't need to replace closing points, okay? Here, all are here, okay? Or all are here. And directions also same, pointing, yeah. Okay, there is some warning, okay, that's okay. Click on, okay. And now we don't need these curves, okay. You can hide this projection, you can hide this one, and you can hide this one, okay. So now, yeah, we have to trim this one, right, inside. So trim that one. So trim what nut pieces standard. So select this one and this one. So it is automatically trimming the inside. You can also use split, but split 2 times you have to use. Okay, and yeah, make this one radius 0.5. So radius that is not given, but assume that is 0.5. Yeah, fillet, edge fillet. Thickness is 0. Radius is 0. Sorry, 0.5. Okay. Yeah. So now what I do, we fill this one, close the surface, right? Close the surface. For that one, I'm going to use part design because I can use generative shape design close surface, but I want to make minor changes here, right? Create hole, okay? Create keyhole here and make pocket and all these things, right? So now it is better to use part design because part design is used producing pads and pockets, right? Part design is most useful. Okay, so close surface. This one is close surface. Yeah, this one, surface base features. You can see this, close this entire surface. And now you can hide this, right? Outer layer you can hide. What is that one? Surface. This one, hide, edge fillet. So what I need is only the body, okay? And yeah, shading with material option is now, shading with material option is shown, right? So you can shading with edges option, okay? Yeah, this one. And now, yeah, trim, chamfer. You can use chamfer. Here C5, right? 5.5 is there, right? Actually, that is C5. There is some typo. So chamfer 5 mm. Okay, chamfer 5 mm, and so we have to make 6 kinds of these blades, right? So I'm going to use circular pattern. Circular pattern, number of instances are 6. And if there are 6 kinds of blades, right, 6 blades, so angular spacing is 60, or if you don't know, 360 over 6. Okay. And reference element is what? X-axis, or you can choose this YZ plane, center of the YZ plane, or you can also choose X-axis. Okay, anything is okay here. Okay, so that one is the fan, and you have to use like these are minor things, right? Pocket you have to use, right? Select this one, create a hole, right? And yeah, so this is 5 and this is 10, right? So from here to circle, this is 5, and this is 10, right? And the radius diameter is 50. Diameter is 50. And now we can trim this, right? We don't need to have this one. You can mirror this, right? Sorry, not trim. I trimmed. So mirror is 3. A mirror the other side, and you can trim that one. Okay. So yeah, pocket. Up to last you can use, our dimension is 250. Up to next or up to last. Okay, complete hole, and again make one more pocket hole, circle, right? Diameter 75. Diameter 75. Is diameter 75. Yeah, make pocket up to yeah, 30 millimeter, right? So there is some hole, 30 millimeter, or not up to, let's after dimension. Okay, dimension depth 30 millimeter. Okay, yeah, and other side also same, we have to make a circle, or you can make a plane here, right? For plane, half of the 200 is 125, right? 125. Okay, from the YZ plane. Oh, sorry, not. I think I choose a different. So from this plane, okay, the front view plane, YZ plane. So you can make circle and pocket is better, right? And make this pocket mirror, this pocket 2, 3D mirror. I want this plane. Okay, and give the fillet. There is a fillet here. Fillet radius is 5 millimeter, R5, right? R5. So fillet. Okay, so